Today we're going to talk about software quality. The first slide just shows you some topics we're going to hit, an overview, actually the definition of software quality, how it's defined, determining the stakeholders and why that is necessary, determining the quality goals and objectives, how you go about doing that, standardizing your software quality plans and processes, which is very important. Standardization is always very important in any of your processes. Tracking and controlling the software quality throughout the software process. And then the final step, auditing the process, which is very important that it is done so that you know the next go around what went wrong, what went right, how to improve, and go from there. So for the overview, basically what we want to do in the world of software measurements or software measures or metrics is to facilitate the delivery of software to the customer on time, within budget, and with a high degree of quality. And we do that by better managing our software products and processes, improving our estimation, identifying best practices and process improvements, and some other things. There are I've done other webinars on different aspects of these, such as estimation and setting up a software measurement program and such, but today we're actually going to drill down and focus on one key part of that, and that is on quality. So we're going to look at how you're going to deliver a good quality product or process, and how, and in order to do that, how you can design, implement, and manage that quality management system so that you are producing high quality products. So first of all, we're going to look at defining software quality. There are many definitions of quality. I've listed here the various definitions that ISO itself has defined, so you can imagine how many definitions there are of quality. But ISO has several here. You see here that we talk about how the process or system or whatever it be meets the specified requirements. The ability of that product or service or whatever it may be to meet the customer or user needs. They talk about the ability to satisfy stated and implied needs, so not just what the customer or client states that they need, but also things they may not state that we know inherently that is part of software quality. That could be anything such as usability. You know, maybe they may not say, you know, I need this particular software product, you know, that's an online system, to have a certain response time or for it to be available 24/7. You know, they may not explicitly state those, but those are the sorts of things that are implied in certain systems. So we need to be able to meet those needs as well. And some additional here we go. Some additional definitions of quality by ISO is conforming to the user expectations, conforming to the user requirements, customer satisfaction, reliability, and the level of defects present. We're going to talk more about defects in a couple of slides. That's a very, very large part of delivering a good software quality product or process. And a last definition that they give there is the degree to which a set of inherent characteristics fulfills requirements. So basically what we're looking at is, were the requirements met, both the explicit and implicit requirements, were they met? Do they have a high degree of reliability and usability? You know, hopefully they have very few defects, and that meets what the customer or the client is looking for, and it meets all the requirements, and it meets it in a usable and reliable way. So I said we were going to talk about defects. Defects is a major part of software quality. It's probably the thing that comes to mind first when you think of software quality, is how many defects are in there. Hopefully none, but that's probably not practical. So basically, by reducing the number of defects that are delivered, we increase the software quality. So again, we have many definitions of what is a defect. Depending on where you look, ITMPI has it, International Function Point User Group has their own definition. The Software Quality Engineer Handbook that I refer to in this presentation has definitions. ISO has definitions. There's all sorts of definitions. So here are just a few of the definitions of defects. First, a problem which, if not corrected, could cause an application to fail or to produce incorrect results. A defect could also be the absence of functionality that was specified or required. So if there was a requirement to put something in and it didn't get put in, that is a defect. Missing, ambiguous, and or incorrect requirements. Now that can go back all the way back to the requirements themselves. You know, it's take it all the way back to the design and writing the requirements. If those requirements are not written well, or if they have errors in them, or they're ambiguous, too general, etc., those are defects as well, not just something that's not working in production, but you take it all the way back to there can be defects in the design, there could be defects in the requirements. Okay, so how do we prevent these defects? Preventing defects will go a long way to having good software quality. So the first bullet there, the most cost-effective way of handling a defect is to prevent it in the first place. I think that's pretty common sense we can all agree upon. Preventing the defects eliminates rework, which obviously then eliminates the chance that you're going to introduce more defects, especially if it's already in code. You go in and change the code. Anytime you open up the code, you run the possibility of introducing additional defects. By preventing defects,